So welcome everyone to the last session of Augmented Intelligence Workshop. As you know, we have been so far exploring how we extend our minds through networks of other humans and our technical networks of various machines. And the workshop is organized by Rob Goldstone, Marina Dubova, Gautam Biswas, and myself. And today we have a little bit different and exciting program. First, we have our final speaker of the series, Kobi Gal, who is the professor at the Department of Software and Information System Engineering at Ben Gurion University of the Negev. And he's also a professor at the School of Informatics at University of Edinburgh. And his talk will be an ideal conclusion of this series because Kobi is working on both aspects of augmented intelligence that we have been exploring here, both artificial and social augmentations. He studies multi-agent decision-making, especially in teams that comprise both human and computer participants. And today he'll be talking about how AI can be used to support collaborative learning. So he's really unifying many of the themes that we were discussing here. And then we'll transition to the final discussion of the workshop with Rob Goldstone giving an initial overview, and then our special guest and returning friend, Rick Dale, who is a professor at the Department of Communication at UCLA and editor of Cognitive Science. He will present his textual analysis of workshop materials that will show, and I know that he will be humble about it, but will show roughly what clusters of research have emerged during our workshop. And then we can all look at it in a psychotherapeutic way and reflect what are some surprising connections, what connections are perhaps not there that we were expecting, what do we need as a field as we progress forward. And before we start, let me just know that this meeting, as you notice, is being recorded and it will be posted on the workshop YouTube channel. So make sure that your microphone is off at all times, except when you're speaking. And feel free to post any thoughts you have in the chat. We will post the chat later on our Slack channel. And after Kobi's talk, we'll take a couple of questions or a few questions specific to his talk, and then go in the general discussion. So you can just raise your hand or just yell at me or moderate the discussion, and I will moderate the discussion. So thank you very much, Kobi, Rick, everyone. And Kobi, please take it away.
Great, thank you so much for inviting me. It's such a pleasure. I'm a fan of this series, and it's an honor to present the penultimate talk today on AI-supported collaborative student learning. Let me start with a bit of definition. What do I mean by collaborative student learning? I mean simply a group of students studying together to achieve some kind of learning goal, and that could be whether inside or outside the classroom. And you may know there's a large body of research in the educational sciences that show that collaborative student learning works. It gets individuals to achieve higher level of learning, retain more information when they work in a group. As opposed to working individually. They engage each other more, they speak their own language. I have to tell you an example from my own undergraduate career. I didn't realize it, but when I was looking to study for exams, I was studying computer science and psychology. I distinctly remember searching for other students, one student who would be better than me. So I will have kind of discipline and be able to follow in their footsteps, and another student that was slightly weaker than me, so I could feel good about myself. So, I was carrying out collaborative student learning even before I knew what it was. You don't really need to see theory to understand that students work great when they study together. And indeed, there's been increasing amount of work on facilitating this collaborative student learning through technology. So computer-supported collaborative learning puts on a kind of a layer that facilitates how students interact, and it fosters knowledge creation and idea development, lots of good stuff. So here the emphasis is using technology to encourage dialogue, co-construction of meaning, and cognitive artifacts. An example is this. I love this application. This is an immersive simulation in the New York Hall of Science that I've been researching, where you see these kids. They're interacting and learning about ecological problem solving collaboratively by directing the flow of water to different biomes and seeing the effects of that on the ecosystem. So they're actually, you see, they can manipulate these logs and then that moves the water virtually all over the floor. This is an amazing application. Another one is GeoGebra. Right here, you're seeing a version of GeoGebra for that people are using in Israel, and they could be students in Jerusalem and students in the Galilee, and they could be working together to explore and solve geometry problems on this combined spreadsheet. So that's the good news. But the bad news is that small groups are optimal, and a lot of research in the learning science shows that unless you have a teacher acting as orchestrator or facilitator, the best technology can never come in lieu of a human teacher. So the problem is that the computer-supported collaborative learning doesn't help us to scale up the benefits of collaborative learning so long as it requires the intervention of a human teacher. And that's exactly where we come in. We want to put the final piece on the pyramid. That is, let's take computer-supported collaborative learning to the next level by scaling up the benefits using AI. And I've been doing a lot of work on using AI to help understand how students learn and help teachers help students learn by kind of sharing the problem solving, heaven forbid, not trying to replace the human teacher, but giving the human teacher tools to scale up the benefits of student collaborative learning. So that's what I'm interested here in a kind of a wide brush. And let me just give you a few examples of work done in my lab that starts to kind of bridge this gap between collaborative supportive learning and AI. So I'm really into measurements of how students engage with course material. And here you can see a wonderful, wonderful paper. I really recommend this paper to be read in every classroom because it's beautifully written. It's called The Cognitive Engagement Theory, and it's by Chi and Wiley. And the idea is you have this pyramid of engagement with class material. So at the bottom of the pyramid, it's students who just stare at the professor speaking a monologue, right? Which is what usually happens. Those are passive, or they're reading a piece of text. But they become increasingly active if they're starting to highlight something that they're hearing in class or reading about. Then they become constructive if they actually summarize. And at the tip of the cognitive engagement, they're interactive. They're discussing with other students. They're constructing some kind of summary and insight about the material. And that's where we want to go, because Chi and Wiley show a causal relationship between the type of task, the cognitive engagement that's embedded in a task, and the effects on learning. So you want students to be as interactive as possible. And again, this should make perfect sense to anyone. You don't need scientific results for that in order for learning to occur in a greater scale. And so my first research question is, can cognitive engagement actually be a useful tool for teachers? And can we combine automatic classification of cognitive engagement with a visualization tool to help teachers understand how students engage with material? And what we did is we extended the kind of traditional cognitive engagement pyramid to an online forum. So today we're learning online a lot, and we collaborated with UC Davis. They have a flipped classroom for 101 biology that's taken by all social science majors. So from psychology to biology, they're all taking this course. So they have hundreds and hundreds of students, and they use anchor-based forum where students can converse about the material. So I'll give you an example of how we adapted the cognitive engagement scale to the Biz 2A biology course. So if you see a student asking a question, then that student is relatively low on the cognitive engagement scale because there's no actual construction of insight. The student is merely asking a question. If the student is discussing material and there's turn taking, as you can see here, there's also an argument being made. That should, of course, be at the top of the pyramid because this message on the forum reflects interactive reasoning. Okay, so far, and of course, the bottom of the pyramid could be something completely off topic on the forum, like who who won the semifinal in the FIFA World Cup today? There are such questions. But we're working with as I said, with the University of California, Davis, and we're using a tool called Nota Bene developed by MIT. So as you can see here, the discussion actually occurs on the margins of the texts. Isn't that amazing? So rather than temporal-based as a traditional course forum, the discussion is context-based. And that has in itself a lot of benefits, because everything the students want to have at their fingertips to discuss a particular topic is in the context. They don't have to scroll up and down and looking for relevant comments that might have happened 3 weeks ago. And so it's a great way of, there's something in the chat, is that for me? Okay, yes. So I'll talk about the connection to Bloom's hierarchy in a second. And so it's a lovely way of interacting with the course material. And I want to say that by having the discussion in the course in the margins of the textbook, it gives you even power, a lot of power to understand how students learn. So for example, if you look at what I'm showing you here, oops, sorry. What you're looking at here is a student who selected some pieces of the course textbook, and their question looks great, but in actual fact, it just paraphrased what was written there. So if I didn't have the context, I would put their comment relatively up there on the cognitive engagement scale. But actually, since the comment is paraphrasing something that's already in the book, you want to downgrade it and put it actually in the active section. So the fact that they're discussing things on the margin and you have the context of the reading material gives you a lot of power to understand more about what's going on. You can actually detect also plagiarism this way if you think about it. So what we did is we worked with the instructors who were amazing in that they helped us by using this decision tree we built for them to manually classify thousands of comments on their forum for their cognitive engagement with this new scale. So you can see we built an interactive tool that allowed them to kind of go down the tree and decide which label to put on each of the threads that they were helping us. And we made sure that there would be as many as a cap, the number of decisions made for each label at, I think, 5. So that was the label decision tree. And then as a result, we got a few thousand labels. I mean, they were very nice to work for us, right? You can't do this every day. Ask course instructors to sit down and help you painstakingly label students' comments. But it does give us some terrific insight into how the distribution of the cognitive engagement lies for different courses. Do you guys still see my screen? Okay, it disappeared for me. 1 second.
We see your.
Everything's cool on your side, right?
We see it not in the presentation mode.
Yeah, so I did something bad. Let me stop share. I did something bad. Trying this again. Show navigator. Nope. Can you see my screen?
We see your screen, but still just the non-presentation mode. Maybe if you just enlarge the slides.
Oh, so the slides aren't advancing now?
You know, it's the, how do you call it? It's not the it was a quick clicker. We see your notes we see your notes.
You see my notes. Yeah, so somehow
yeah.
Oh dear, somehow this got screwed around. Let me try to just disconnect the notes. I'm sorry about this.
Of course.
This should do the trick. What do you guys see now?
Nothing yet. Did you share? Oh, no. It's coming. Now we see your desktop.
I think it might be fine, but you haven't started the slideshow yet, right?
What do you see now? Is it advancing?
No, you haven't shared the screen yet.
Hold on. Okay, this should work.
And if you now start a presentation,
1 second. Do you see anything?
now we see some kind of view where we see a couple of slides and the notes.
1 second. This never happened to me.
It's the challenge the augmented parts of our intelligence are posing to us as the new problem.
And now?
No. Maybe this button will do it. Yes, that's
Great.
it.
So you can see a distribution of the cognitive engagement for 2 courses, biology, which is what I spoke about, and physics. And if you, it's interesting because if you look at that, how the students kind of differ in threads that have low and high CEs. So threads with low CEs are more associated with short comments, with questions, like I showed you in the example, first posts and paraphrasing, where high CEs are more associated with longer comments, with students that are interested in material, and they come later in the reading material as opposed to earlier. And one thing I want to make with respect to Rob's comment on the Bloom taxonomy, so it's important to note that cognitive engagement does not, it correlates, but does not mean that students understand material. So you could have a student who is highly engaged, but they're not representing a correct understanding of the material. And I actually have an example of that. So here you can see a student talking about pH. And so the reason why pH is so dangerous to consume is that it's that it's poisonous to eat, and that's really not true. So despite this, the student is discussing something with other students, and therefore this comment received the high CE. So given that we have the ability to understand what makes a thread high or low on CE level, can we also train computer models to help teachers in future courses? Because you don't want teachers to have to sit down and label comments before every class. So we do that by allowing, designing these automatic classification tools for CE. So the input is like that is the course forum and the reading material in the course, and the output is a designation of the cognitive engagement level for every thread. And I won't go into the details, but we used a variety of different techniques. These days, it's all deep learning and BERT models that are crunching away at the data. And if you're interested, I can give you more information about this offline. So we built visualization tools that then provide teachers with this kind of heat map, where based on the inferred cognitive engagement levels of different areas in the textbook, this gives the teachers a lot of power to actually come into the classroom and allows and understand where students are experiencing difficulty, where there are sections of high and low CO, And this was very interesting because we did user studies with the teachers, and we saw that they related to the visualizations really differently. So as I'm sorry, didn't say this, but the heat map allows you to kind of see the range of different CE levels on every portion of the textbook. And the teachers really differ. So the instructors are mostly interested to see what students get right. So they're interested in the high CE, whereas the TAs are more interested in understanding where students are confused and don't understand. And the use of the heat map allows them to kind of carry out this distinction in the classroom. So I think that's a wonderful, wonderful example of how to get it right by kind of combining the AI with the ability to help students read material and answer each other's question. I should say that in this split classroom course, the heat map turned out to be extremely useful because the students' instructions are that they have to submit their comments by 11 p.m. the night before class for a variety of reasons. So what time you think do the students actually submit most of the comments? Obviously at 10:59 p.m. And then the teacher kind of really relies on some sort of help in order to be able to design and understand how to carry out the next classroom. So given that I only have a few minutes left, I want to talk about scaling up collaborative student learning in a real classroom experiment. So what we did here, this is a joint work with Baruch Schwartz of the Hebrew University, is we took the principles that I showed you earlier about understanding cognitive engagement and try to implement a kind of friendly parrot on the shoulder for each of the students that communicate in a smart way with the teacher. So I'm not now talking about a biology course, I'm talking about GeoGebra, which is a very common tool for learning about geometry. And as I said earlier, we're turning it into an exploratory learning environment, but by giving students these kind of open-ended questions. So for example, this is translated from the Hebrew, what quadrilateral, if you dissect the diagonals, you not only get equidistance in the diagonals, but also 90 degrees. And one of the possible answers could be a rectangle. So it should come as no surprise to you that when a classroom, say in an average school in Israel, they have 30, 35 students, a teacher cannot clone her or himself to provide support for each of these groups working individually or simultaneously. You would have like 6 or 7 groups of students, and teachers, what they can do at best is either forsake some of the groups altogether, or do a round robin and always have to context switch, right? So neither is a good optimal solution. So what we're trying to do here is kind of give teacher the ability to have a bird's eye view on what's going on all of these groups. And again, we use the power of AI. Here we trained a model on just 3 types of tasks. So we started this of course is a very rough designation of types of learning tasks, we called it the critical moments. In a group's projection, you could think of others that are far more fine-grained and interesting, like a student claiming a fact or another student ignoring it. All of these are interesting to look at. We only looked at these 3, and we collected examples and trained a classifier that helped us kind of build this intelligent alert engine with lots of different kinds of alerts. So when a teacher is operating collaborative student learning in the classroom using this system, we call it SAGLET, a System for Aggregation Group Learning in Educational Technologies, they get a kind of a bird's eye view, like an air traffic controller. Here you're seeing 3 rooms working simultaneously, and the students are chatting, and the teacher has a kind of an online, a color-coded alert for what's going on with the group. And for some of them, we don't even need AI, like to find out that the students aren't working. You can just look at the interaction log in real time. But for others, we do need this kind of supervision. And we carried out controlled lab study where we worked with a few teachers and we tracked how they use Saglit, the system that we built, in various situations. And we found that indeed with this scaffolding, with help, the teachers were able to track groups with minimal burden and were able to intervene when they wanted to and kind of nudge and push the groups. And the example that I love to make about this is that I saw a teacher getting an alert from the system that the students were off track, and she didn't intervene. She said, "Oh, this is right. They're completely off track, but I love what they're doing. I love the discussion, and I love where it's headed, and I want to keep it that way. So I'm not intervening." And I think this is a wonderful example of how you can kind of combine the human intellect and experience with the power of the artificial intelligence. So here you can just see the types of interventions that teachers were doing using the system. And I'll end the talk by a video. It's not going to have any sound, but you can actually see the experiment in action. So this was in a school going on in Israel. We did lots of experiments. We also had Jewish students and Arab students talking together. Here you're seeing students working in the classroom, and although they're all seated near each other, they're only interacting with the system. So as far as the system is concerned, one could be in China and the other could be in the States, and they would be working together on GeoGebra, trying to come up with exploratory learning to the best way. And then the teacher is able to use the system to kind of intelligently control what's going on. So that's the end of my talk. We're doing a lot of exciting stuff these days that combine AI in education. And I really think this is the holy grail of AI. Whenever, I have another hat on, I'm a hardcore AI researcher, and I always tell people that education is the best and most wonderful socially relevant problem to explore with AI. And if you have any other questions, please don't hesitate to contact me. Thank you so much.
Thank you very much, Kobi. That was fantastic timing, also given a few technical problems, and it was a very engaging.
Yeah, that was horrible. I'm sorry. That never happened to me. I switched. I did something that switched the screens. Anyway,
no,
yes.
it was all good. It was all good. And so your talk provoked a lot of questions. Does anyone want to raise hand, or I can, while you're finding your button, I'll start with some that I noticed. There was some discussion at the beginning in your the example of automated classification of cognitive engagement levels. What was the AI doing, basically? Can you just summarize in a couple of sentences?
Yeah, the short answer is supervised learning. So what we're doing is the input is the reading material and the students' comments, and the output is the cognitive engagement designation.
Mm-hmm. And then related to that, who was asking? Danielle, I think. Was there an association, or can you again summarize what is the association between cognitive engagement level and learning or performance? You mentioned the association with understanding, but can you comment a little bit more?
So that's not my research. That's Chi and Wiley. So I didn't do this because you have to carry out a randomized control causal study, which is extremely difficult to do in a classroom. But they really, what they did is they had several sections in classrooms, and they limited the kind of activities that students could do to explore different aspects of the cognitive engagement scale. So some students could talk to each other, some students couldn't, and that's how they kind of controlled and came up with a causal interpretation of the types of learning actions students could do and their learning performance. Again, read that paper. It's an amazing paper.
Great. Thank you. Kote, did you want to ask your question about cognitive tutors?
Just a very general comment about cognitive tutors. There have been decades of work by Anderson, Cottinger, and others on cognitive tutors. And it wasn't clear to me what the connection to that work is.
There's very different environments. Cognitive tutors and exploratory learning environments are extremely distinct. We care about environments that are totally open, where students don't receive a kind of a tutor providing them with questions at every step, but are rather left to their own devices to explore and to build models of the world and run the models and analyze the results. So the idea behind exploratory learning environments, which is the premise of all of the environments you've seen today, is that students need a rich avenue of learning actions to succeed. And the cognitive tutors operate in a much more constrained environment.
And more personalized, I would add, would you agree with that?
And more personalized. Oh, that's a great, yes. But the cognitive tutors provide a personalized guide to different students, yes. And you can indeed also think of a work that I haven't shown today, but could potentially be possible, where the AI support is also personalized in the ELE. But yeah,
Okay.
thank you. So
Yeah.
I think each of these environments has is important for in their own right.
Thank you.
Mark, apparently you had a question that many people wanted an answer to. Would you like to ask it?
Sure. Yeah. Thanks, Kobi, for that great talk. The classifier you mentioned has, I think, 4 levels of cognitive engagement. And you mentioned this example of instructors and TAs looking at this color-coded scheme. And what they got out of it is mostly like, are they engaged or are they not engaged, or degree of engagement? Do you need the 4-level classification for that? So is there something particularly important about distinguishing between level 2 and level 3, or level 3 and 4, right? Is the power of the AI needed here? Or can you do something really simple, like, how many comments do people create? Or
So, okay, so first, great to see you here. And the short answer is that you do need more than just how many comments there are. The default histogram in the course forum that we saw, it does indeed provide a distribution over the number of comments, and it's just not good enough. So we know from interviewing teachers that they need something more. Now, do we need do we need the diversity of 4 as opposed to 3 or even 2? That I don't know, and we haven't studied that, and that could be an interesting question. There might be some more simple things we could do to already give the teacher some kind of boost without taking out this heavy machinery of the multi-classification, which is indeed more expensive to train.
thanks.
Thank you. Charlie, would you like to ask yours?
Yeah, thank you so much for this really great talk. I was just wondering if this the classifier distinguishes between situations where kind of you have an average level of engagement across the entire classroom, or you have some individuals are very highly engaged and some other individuals are not, right? And so I'm wondering about this question of equity in terms of kind of like how well it attends to the needs of all the different students in the classroom.
Yeah, so the sad answer is that when you look at individual students, you see that they're all in their kind of little window. So they vary, they go up and down, but there are differences between individual students, and we didn't see a lot of transition from students who happened to be low on the cognitive engagement and then increased, and also vice versa. It was pretty static, and it's very important to build. This is something we're working on currently, to be more interactive, and in the forum to try to nudge students out of their zone, out of their cognitive engagement zone. We're doing that by seeding, for example, the forum with past comments that we think generate high cognitive engagement discussions. So thank you for that. That's a very good
maybe
question.
just a quick follow-up, and this is somewhat related to Mark's comment about the classifier, right? You can also have a supervised regression model, right? So a regression model will then maybe also allow you to kind of quantify, are we having high expected engagement across all the individuals, and also something about the overall kind of variability of engagement across individuals. And that's going to be another important variable to look at, because are we just optimizing?
You're absolutely right.
Or are we actually getting the kind of some lower bounds of engagement in the classroom above some threshold?
That's very true. I also want to emphasize that we have a very kind of low bandwidth about engagement here, right? Because all we see is what students do on the forum, and it doesn't. And engagement is such a rich concept, and it doesn't look at what they were reading and what they were discussing and how good they were in the homeworks, and all of that is invisible to us. So we're only scratching the surface about what is engagement really. It would be great to have more, to compute more fine-grained values like the one you were suggesting. That we would need to have more information, I think.
Great questions, discussion so far. I'm aware that Kobi needs to leave in a few minutes, but perhaps we have a time for one or two more. Jianwei, would you like to ask yours?
Okay, thank you. This is Jianwei Zhang at Albany. Thank you for the great talk. I was, once thought about where Mark was commenting about is, whether you really need AI to really look at the different, multiple categories or just off topic, on topic. I think, that pushed me to think about, how the feedback is not only just helping the educator or teacher to decide whether intervention is needed or not, but also what kind of intervention. If we really can pinpoint the different type of thought in the conversation, that may help the teacher not only detect the group to intervene, but also like what's the most helpful kind of scaffolding they may need.
I hear you. That would be
Yeah, I have two brief questions. I think should be simple. One, what's the unit of analysis in deciding a moment of engagement in the conversational data? The second, did you also consider like a face-to-face data as well, other than the online posting?
What do you mean by face-to-face?
Like I see that in the video, the students are on the screen, but also they're talking to each other, right?
Yeah, so we did. So the short answer is no, we didn't consider the face-to-face. And the level of measurement of CE, was that the first question?
The unit of analysis, how did you, for example, did you apply the code or category to each conversation turn, to a whole thread of replies?
To an entire, so yeah, the unit of category was a post.
One post.
Yeah.
Okay.
Yeah, and also the unit of category, it's further distinct by whether it was the first post or a follow-up, because first posts are usually lower on the cognitive engagement scale, so because they ask a question, whereas follow-up posts are usually more because you have to follow up on the post, you're interacting, so they're higher. So we also controlled for that. That was an important piece of information.
I bet like some of the category, for example, interactive, is only visible when you look at the whole conversation thread, right? Multiple posts, and look at how they are relating to the other, not just textual feature in each post, but how they relate, complement each other, and get deeper in the meaning or in the understanding.
This is very true, and let me just add another thing. I mean, we want to get the students to learn more, right? The students don't like the flipped classroom, even though that there's all of the, even though that they learn better. They have to reach out, read the material, and come up with questions before each class. And as you can imagine, most of the posts are questions. They don't like to answer each other. They want to do the minimum amount of work to carry out the 3 comments that they need to do for class. So again, that's another thing that would be wonderful, is whether we can nudge students to be more interactive before the classroom, and again to kind of nudge them to be better learners. And this is always it's a two-sided coin. You can't have students, you can't overload the students, but at the same time you want to make them come to class with some sort of insight.
That's great. Thank you.
Yeah, thank you so much for having me. It was a pleasure.
Kobi, thank you so much that you provoked a lot of cognitive engagement here. I guess also some understanding, and I know you need to go. Thank you. We'll see you another time, hopefully. And now we continue with the even more cognitively engaging part of this workshop, where we are grateful for Rick's willingness to ease us in. But before that, I give the word to Rob, who might have a few summarizing words to say.
Sure. Yeah. So I mean, overall, I guess my big summary is just to say what a fantastic ride this has been. It is, I've learned a ton. I guess selfishly speaking, this has been really good for me. I've learned a lot. I've had a lot of fun doing this. I want to thank everybody for their participation. It's been great to have a core set of participants who have come to a lot of our sessions. I've been super gratified that even after people have given their presentations, many have come back to hear other people's presentations, which is what we were originally trying to achieve, but I'm super excited that it worked to some degree. I've enjoyed the back channel chats that Zoom has allowed us, that we've seen today, and even the further back channels like Slack and Jamboard have provided. So I wanted to thank Dr. Susang Lim, who is our Cognizant National Science Foundation Program Officer for the program in Science of Learning and Augmented Intelligence. Needless to say, the workshop couldn't have happened without her support and without NSF support. I want to thank my co-organizers, Mirta Kalisic, Marina Dubova, and Gautam Biswas. It's been a pleasure doing business with you. Particularly grateful to Marina for handling the daily feeding and watering of the workshop. And that has required a lot of work. It has a lot of moving parts. Although the workshop presentations are over, there is one major activity related to the workshop that is only now just beginning to kick into gear. And that is, we have recruited 7 rapporteurs to prepare reports on workshop themes and hopefully publish them as perspective pieces, review articles, introductions to special issues, and lay audience magazine articles. These rapporteurs know who they are. Some of them are in the room with us right now. I'm looking at you, Charlie, Rick. They will be putting what we've learned in this workshop about coordination to self-organize themselves to coordinate also with the speakers. So look forward to seeing these reports come out. So one of the things that I'm hoping that we can do today is talk about some of the lay of the land for what these reports should look like, what themes we should be covering. And to help us toward that, we have invited Rick back again to give his NLP/AI analysis of what has transpired during the workshop. Mirta, did you want to say more by way of introduction to Rick?
That's it. Thank you, Rick. As you know, Rick is an editor of Cognitive Science. We all interacted with him in some way or the other, and he presented last week. He had this great talk about large language models, and he made the mistake of analyzing our workshop materials, and we jumped at him and said, Rick, please come to our summarizing session. So here he is. Thank you. Please take it away.
Okay. Thanks for having me back. And I guess let me share my screen then, because I have a few slides I can share to hopefully prompt the discussion. And so for those who may not have seen the talk last week, I should add a brief preamble that I'm probably not the best person to be presenting these notions of AI. And one of the reasons that I presented it last week was it was an interesting prompt that linked to the provocative topic of the workshop in ways that I was very excited to talk about out loud, to think through some of these questions. And so there are some on the call here who probably more expert in a number of ways than I am. But anyway, the purpose of last week's presentation was to showcase some ways in which student Zachary Rosen and other collaborators and I are trying to integrate large language models as sources of measure, but to think of them as potentially interesting extended cognitive systems that we have interesting intuitions about what they know and what they do and so on. And we're now utilizing them as, I hesitate to use the word oracles, but they're sort of sources of potential rich measurements that we are using in systems of interaction, such as human-to-human interaction and coordination and so on. And so last week I gave a series of illustrations of how you might use these kinds of techniques to extract measures. For example, one large language model that we're using extensively because it's very flexible and easy to deploy and fine tune and so on is BERT. And one of the illustrations I gave last week that prompts these few slides I'm sharing with you right now is I took all 41 and actually integrated Kobi. So I have all 42, which is a great number of abstracts, of course, 42 abstracts in the workshop. And what we can do with this model, it's very flexible. It allows for a wide variety of new kinds of measurement. So the kind of contemplative discussion I shared last week, maybe a bit rushed and so on, was this notion that, we can see this extended system as a highly flexible way of doing new kinds of analyses and extracting new measures that we couldn't before. So the illustration I shared here was to take these abstracts, your abstracts, our abstracts, and use them to essentially recover each other under a kind of information theoretic measurement. And so in other words, I can take Danielle's abstract, I can prompt BERT, I can contextualize BERT's, the model with Danielle's abstract, and I can see how well it recovers, say, Mark's abstract, based on some cosine measures that are underneath this hood that I'm happy to share more detail about and so on. So what we can do is do all such pairwise abstract comparisons among everyone who's presented at the workshop. And we can look at potential relationships among speakers by wiring them up together based on those relationships among their abstracts. And so I'm just going to show you one plot that I showed last time. You can, for example, here's a network of the abstracts of the speakers. Essentially, I'll use the names here. So we'll all be hunting for our names on this network as I show it here. Wiring up everyone to their two closest recoverable other speakers. And so this is what the network looks like. So we have hubs. This is a directed graph because you have abstracts that are recovered by prompting BERT with another abstract. So you have potential asymmetries that might be interesting to look at, and also mutualities. And I'll just leave this up for a second. This is a bit noisy. This is a completely non-fine-tuned large language model. So it is possible, for example, to take some of these systems, fine-tune them using maybe some of the wider literature on these topics. But in chatting with the graduate student, Zachary, we decided that we really do need to have some nice baselines that compare to other kinds of semantic systems that we've used extensively and might like to compare to. So I did play with LSA a little bit. So I created a bespoke LSA model, almost irresponsibly too small, on only 42 abstracts to see how the network would look under a more familiar latent semantic analysis lens. So for those who don't know LSA, although I imagine many on the call know LSA, it's very similar in a sense. You're looking for embedding vectors. We're looking for a numeric representation of words. But LSA is, in a sense, considerably simpler in that we're just essentially looking at the ways in which words are distributed over the documents that we have. In this case, 42 abstracts, and they're about, when I removed stop words, and there are more details which I won't go over, but they're about 1,800 words or so. So an 1,800 by 42 dimensional matrix. And so here, what LSA does, it's very simple matrix. It's a dimensionality reduction method where we're just looking for some shared variance across the documents. And so let's wire it up with a more familiar semantic model from cognitive science. And the results here were more compelling. And I think one of the reasons for that, of course, is that this is a bespoke model that's really working from the internal structure of the abstracts, the 42 abstracts. So now I'm going to create a graph here. I'm going to show you a graph where we're just wiring up your closest neighbor. And this is a non-directed graph because you just have cosine, you just have semantic relationships that are symmetric between abstracts. Here you go. So I'll just leave this up for a second. Fun. I mean, you see some clear overlaps in terms of, I know this is just, of course, a very critical caveat, of course, is this is sheerly driven by lexical frequency. I mean, there's a sense in which it's a very shallow model. Nevertheless, there might be patterns of interesting indirect co-occurrence that might be valuable to think about as well. So Mark's talk and Mike Richardson's talk, for example, involved some coordination with AI in interesting ways. Obviously, some of the talks on learning and education and feedback systems and AI are clustering together. So here's another graph where I wire up the two closest neighbors, and now we have a completely connected graph. There are no subgraphs. I don't know if you're seeing any themes pop out. No. Let's zoom in. Here we go. So we do some simple things just to see what kinds of themes pop out here. So I can look, I can color the nodes here by their use of particular terms, and you can see these themes pop out naturally. So here's education and student. Here's another one. Collective or public. Obviously, there are outliers and some that don't abide by this particular potential interpretation. Others that have maybe a direct relevance to maybe supplementing or involving direct cognitive measures, such as decisions or perceptions. Choice. And in working with this a little bit, so just to end here, I'll end right here, but I wanted to at least playfully end on a kind of maybe abduction in this case, because it's sort of hard to read through it, but I'll call it induction. It may seem maybe less like a leap. Anyway, one obvious possibility that pops out of this clustering here is that a key question about augmented intelligence is the scale of the intelligence that we're seeking to augment. So we want systems of knowledge at the public or collective sphere to have particular kinds of sound characteristics. And you see this in a number of talks, such as in Steve Lewandowski's talk about debunking and so on. And so this is obviously a loose characterization. It's one, like any MD, like classic multidimensional scaling, you look at a two-dimensional projection, and we're trying to interpret it here. And then you have more local considerations where it may be about a classroom or about even a single learner with a system that's meant to augment their learning. And then the other dimension, which I am less confident about, and it seems almost simplistic in this way, but I'll call it the potential focal unit of behavioral measure. So the idea is that, for example, in Mark's talk, where you're trying to improve perceptual classification and create a system where you have humans and AIs integrated in ways that achieve a particular kind of signal detection and so on. There's a sense in which the locus, the individual performance measure, really can be isolated to an individual instance. You can identify a particular well-formedness in a given decision that you're seeking to augment. But in the case of, say learning, it's actually a much longer kind of timescale where you're looking at the potential impact of a feedback system that's actually meant to coordinate over longer extended periods of time in order to supplement maybe something that's you're seeking to establish over that longer period of time. And the same may be true, for example, in the bottom left here, we're seeking policies for collective systems. These are systems at the collective scale that we're seeking to sort of establish a relatively stable form, but these can be more or less stable. So Marta's talk, for example, is about adaptation of these kinds of systems under different kinds of constraints, or Rob's about taking on particular roles and such. So I wanted to end on this at least speculative idea about the way that this two-dimensional projection may be interpreted. And I have a variety of other things. So Mark's here. I did a little bit of LDA as well, but I'll stop. That was about, I don't know what that was, 12 minutes, 13 minutes, but I'll stop now.
That was perfect. Great, fantastic. Thank you very much. Maybe it makes sense. Awesome. Maybe it makes sense to keep either this slide or whichever you like most, or we can change them. Now, we can look at it all as a Rorschach test for us and see what do we think of it. What are how do these themes correspond to what we have in our minds? Are there some connections that are surprising? Are there some connections that are missing? What would you say? What would you all say? For me, the slide has vanished right now. Rick, is it just me? Yes, thank you. In the meantime, while you're thinking of that, Rob also posted a bunch of possible topics or ways to summarize the workshop themes in the chat. Rob, do you want to say just a few words about that?
So there are 7 themes that we're trying to figure out how they would be allocated to these rapporteur reports. So these are very preliminary. And a lot of them, as Rick was alluding to, are getting at the real core issue of how should our new AI technologies, our new machine learning technologies be somehow helping people to do better jobs than they would be able to do otherwise. How can they create infrastructures? And I'm trying to avoid using this term that like Chalmers and Clark have talked about extended mind, because I think there's a sense in which that's in some ways even prejudging that we are the minds, that individual human skulls are the minds, and they are somehow being extended to be more broad than they would have been otherwise. Whereas many of the talks have been talking about creating fundamental different cognitive units by combining like two or many people, in which case you're not extending from just like a single mind to give it more capacities, but you're really creating different units. So obviously many of these themes are going to be talking about what are those relationships among people and between people and the tools that they're creating to help them think better. So have I stalled for long enough, Myrta, so that people can chime in? Because I think part of what we're trying to do really is to somehow elicit the crowd wisdom here to help us identify themes that we've missed, or to help us figure out how these things should be organized in different ways, such as the way that Rick was proposing, using a sort of a rotation to the MDS space. So I think I prefer to just shut up and listen to you.
May I just ask a clarification question before we proceed? Rick, how would you interpret the differences between this analysis and the first analysis you said you had, where abstracts were predicting, basically try to reconstruct each other's abstracts?
Yeah, that's a great question, and I was concerned about that as well, because they are correlated. So they have about, just the raw numbers without any transformation, they have about 10% of variance in common, and so they were probably, you'd probably find some similar clusters, but there is, it depends on how you interpret BERT's prompting when you're generating those probabilities from BERT. There's a sense in which you're contextualizing an abstract relative to another abstract. There could be other factors at play, such as stylistics. Obviously, the use of particular terms is probably going to be the most dominant force there, but particular kinds of phrasings may also impact it, whereas the LSA is purely a co-occurrence. There's no sequential structure to LSA whatsoever. It's purely words co-occurring. So I think BERT is probably going to have a little bit more sequential knowledge there, which could it could have some noise, but it also might have some valuable signal about the way things are phrased. But LSA doesn't have that, and that might be another reason why LSA is working better, because maybe the concept of level is really key in this kind of analysis. Hopefully that made sense.
Yes, thank you. All right, collective. What do you all think?
I do wonder about Rob's note about unit of analysis and the sort of worrisome parlance of extended mind. I guess I sympathize with that remark, and I guess I'll just sort of contribute with a question, because when I was doing this, this thought came up myself, is what we think of as a system to begin with. What system is exhibiting the intelligence that we wish to characterize to be present in a given situation? What's the locus of it? It has interesting ontological ingredients philosophically, right? I think we carry that forward in a lot of cognitive science, for example, in the way we think about the individual cognitive agent. But a lot of the talks, Cody's talk and others, about integrated human machine systems. What are the ways in which it alters our sense of what the systems are to begin with? And can we think of these as integrated systems that we anchor to as really fully integrated systems with intelligence unto themselves. Those philosophical questions. I'm very interested in hearing others' impression of that.
Yeah, just to amplify that a bit, Rick, it seems to me that like individual people kind of want two things that are really, to me, somewhat incompatible with each other. They want to be in control. They want to have like these slave machines that are doing what they want, giving them exactly the information they want. And at the other side of things, people also want to be part of bigger units and create things that they are not intending themselves. They want to be part of something where they don't know what that thing is. Like if you're imagining improvisation between jazz musicians, that part of, I think, what really motivates them is creating these works of art that was in nobody's mind ahead of time. And so I think there is, to me at least, a tension between those two different things that we're trying to get out of our collaborations, both with other people and with machines.
Rick, could you also show the first slide that you had? I just want to look a little bit more.
Yeah, sure. I could also show you the LDA. I hesitate to do this because
Okay.
I'm in the room here, but if I could, oh, you can also, we can use the term vectors and we can look at the relationship among terms. But I think a better method for doing this is to use LDA, which is another kind of semantic model that decomposes your documents into terms and topics. And so here you can, if I use a different network rendering algorithm, you get the set of topics here as well. So the hub topics, terms that are used that interconnect the topics that compose the abstracts of the talks, include knowledge. Knowledge intersects a number of the topics that were induced by this method. Learning is here. So there's some similarity in terms of the topic induction that I had done more casually in the other one. So I'll let you look at that for a second, and then I'll jump to the first one as requested, unless you'd like me to stay here. Go to the first one. Okay. You can still see my screen.
Yes.
Okay. Here we are. So this is the two closest neighbors. In terms of recoverability. So contextualizing BERT, for example, with Kobi's abstract, leads to relatively low entropy on recovering Mitch Nathan's abstract. Just to recap what's going on here.
Seems that in many of these plots, there is still a relatively clear division between people who work on cognitive social aspects of collective augmentation and people who work on educational applications, right?
Yeah.
Does so that's, I mean, that's not surprising also, because these two communities have not been so connected before maybe this workshop, although of course they are all very much overlapping conceptually. But it strikes me as something where further collaborations would be useful. Christina, what do you think?
This whole analysis is really interesting, and I already put it in the chat, but this look at the Tud Fellows collaboration network and how collaboration happens and creativity happens by an ecological, like he usually studies ecological food webs in Yosemite, was looking at collaboration, not just along that similarity of like who's talking about the same things and that their ideas are close together, but how to get like a shadow dancer collaborating with a data scientist, like something that would be completely on the opposite ends. And those to me are the connections that aren't there that need to be made. Obviously, you don't want the whole network connected to everything, because then everybody's in cognitive overload and you can't do that. But like, what does the field need where, you know, the social scientists aren't being listened to by these like deep down in the stack computer tech server literate people. I don't know. So I really recommend it's like a 6-minute talk on the ecological structure of collaboration. And Eric's brilliant anyway, coming in from an ecological point of view. And I guess the last thing I'll say to that is that we are a living system. Like it's not a metaphor to take an ecological view, because we are all bounded living systems as humans. And then as we interact, we're changing each other's brains and literally brain structure by the relationships that we build. And I guess that's what I see missing in this, is like the relational resonance that people find that aren't in sort of large language model keywords.
Yes, thank you.
So if I could just interject, I completely agree with what Christina was talking about in terms of people shadowing each other in parallel, researching very similar topics and not realizing it. And I've just been amazed at the extent to which that is true in our own field of whatever you'll call it, augmented intelligence or collective behavior. You know, and obviously it's because different fields are playing a role in it, from sociology, economics, computer science, psychology, and I think Myrta has written a lot about this, about how the same terms or different terms are used for really basically the same phenomena, like complex contagion and threshold models and decision making. So I think that's a funny example, kind of how people who should know better are falling exactly in the same trap of diving deeper into their own silos.
I'd also like to call on people who are in different in these graphs. Some people appear more central or in particular roles and have high between centrality or something. Would anyone want to speak up and say, "Oh, I'm surprised to see myself here," or "I'm in an odd company"? For example, Mark and Koti, you are here in the quite central, and Celia, you're also. It seems that you're in between. You're connecting certain clusters. Would you like to comment on this? How do you see this?
My centrality really surprised me. I kind of had my head down as Rick put the graph up, thinking I was going to be absolutely on the periphery. So I am surprised. I found it interesting that, once I saw the graph, yes, indeed, there's a gradient of whose work I knew before these seminars, which is a kind of a validation of this methodology. While I'm here, maybe I could amplify something that Rick and Rob said about the extended mind idea. Find it fascinating when philosophers get into that, but it doesn't seem to be a good fit with the preoccupations of the people, involved in this series. And why might that be? Well, I think one reason is to do with how enduring the collective intelligence needs to be of interest to us. So it seems to me that people who talk a lot about the extended mind are really interested in, what is the entity that goes through, a biological generation or something like that. I think most of us are pretty happy with the idea that you could have a collective intelligence, whether it's composed entirely of human bodies or whether it's partly AI, which is very real, very genuinely collective, but exists very briefly, and that a biological individual goes in and out of it and has a number of them that they go in and out of and so on. And it seems to me that the whole extended mind idea isn't a good fit with that timescale.
That's a good point. Anyone else?
Well, I was definitely surprised also. And I'm still trying to understand what is it that causes the produces those clips. So I guess I would need to go back to Rick's talk and understand really the relationships better, because I just don't know why, right? Why do I appear, would I, or yeah, why would I appear so much connected? I didn't expect that.
Yeah, and I should note that an important caveat here is this is a first pass. Also, it is, you know, I hesitate to use this term because these are great models, but they are shallow models in the sense that, you know, they're driven by particular kinds of structural characteristics of language and so on. But I just wanted to mention as well that as part of the workshop, I'll create a GitHub repository with the code here and the data, all the abstracts. If anyone would like to take a look or comment, and I'll update it as things change, if they do, because I think that this is certainly preliminary, and maybe yeah, go ahead. Sorry.
I'm sorry, Rick. Is it the sequence, perhaps? So does the sequence matter? The sequence in which you consider the abstracts?
Yes, it can matter. So you can get mutual prediction, but sometimes you can get subtle asymmetries. But also, your question also prompted another thought as well, is that certain terminological sequencing might have an impact as well. So if you use a particular bigram, as it's called, or you use particular sequences, it may actually facilitate these measures as well. So these are, you know, systems that should be interpreted very, very tentatively, of course, but it is. But I agree with Myrta. When you look over this, there are particular thematics that do pop out, but the nature of hubs and whether it's sort of rooted in conceptual structure of the abstracts versus, say, some other kind of linguistic ingredient would be key. And also, like, just to echo something Christina said too, I like the idea that in being informed by these graphs, it might be interesting to think about collaborations as how many hops you might want to jump. You know, if this is an interesting potential approximation of current similarities, you might find similar work that's a neighbor, but there might be interesting ways in which distance on the graph may actually predict in some way auspicious potential collaborations, not locally necessarily, not too global either, but maybe in some intermediate zone. But anyway, I just wanted to mention that too.
Yeah, very interesting. Thank you.
It's one approach we've taken in the visualization community. So my life has been an IEEE Viz. You do the LSA, you build a network, you present it, and Battelle does this with their Inspire software. You produce an interface that allows people to look at what words were driving the connections. You'll pull out words that might be just, you know, normal speech, ways of speaking, you know, that are kind of irrelevant. You then let it recalculate again, and you go back and forth in this kind of mixed initiative form. The software is called Inspire. And then based upon that, you'll move to another decision process, which is also graphically derived, that looks at analysis of competing hypotheses and so forth. And so this kind of approach is something that can itself be made iterative and sort of human AI teaming.
Yeah.
Before I call on Ion, Rick, may I bother you to go back to the LSA analysis, because it's just reflective. It occurred to me to Celia's comment about kind of time scale, right, and the duration of the individual that we are, or the level of intelligence that we are studying here. And one of your dimensions was related to time. I wonder if that's just interesting to look at and ponder a little.
Yeah, and also just a quick response to Brian too. I think it's a really neat idea to make it interactive, and maybe that can be done on these particular data as well. Anyway, here you go, Myrta. Here's the.
And then another thing that pops from this presentation is the methodological groupings, right? I mean, Jeremy was presenting work on virtual reality and this very large scale experiments. People like David Garcia, Amy Goldberg, they're analyzing large textual corpora. And then there are some more kind of or maybe more traditional cognitive science people towards the left, and then people who are doing both, like Mark is there again on top left. And then again, the educational component in the right-hand side. So that's perhaps now when I look at it, this graph really goes more deeper into the differences in the field. Jon, what do you want to say?
Yes, thank you. I just want to echo some of the things that some of you have said or alluded to earlier. I get the feeling that the view on intelligence that we talk about, and it was definitely reflected in this workshop, is one that is somewhat disconnected. It's anthropocentric, technocentric, and it's disconnected from its life support, really the basis of intelligence, which is life. I think we also need to talk about the goals, the purpose of intelligence. We kind of assume that intelligence is adaptive, but adaptive in which way? If we are becoming more and more efficient, effective in our narrow kind of world, and we're destroying our life support, then is that really adaptive long term? So I just wanted to say that again, maybe it was implied already in what you guys said.
Celia?
Well, just a brief response to Jon, that I do remember that there was a talk by Deborah Gordon, which was about the teeming life of ants and how that embodies collective intelligence. So you may be using life in a slightly different way, but I don't think the series has really neglected biology. And if I may, I'd like to just pick up on what Meta said about, was there the time scale in this map that Rick's got on the screen at the moment? Not explicitly labeled, but I'm wondering about that space dimension, which Rick said was speculative. Was it collective local that this was representing? I mean, another possibility is that there is a kind of a timescale element in that. I mean, lower left, insofar as it includes people like me and Paul Smaldino, is talking about, cultures, a whole culture as representing a collective intelligence, and cultures are relatively enduring. And on the other hand, you've got, some of the educational work. Is this, maybe I'm confusing maps here. I'm thinking that some of the education work is more in the upper right, where the collectives are pretty brief, like today, a group of students get together and they talk to one another, and it may not even be the same group of students next time that they're doing some collaborative learning or whatever. So it could be that there's a temporal factor in that dimension.
Ying? What do you think?
Yeah, I really like the network map. So I'm thinking of the time and space probably from a different angle. I'm more thinking about the evolvement of the field. For instance, time. So how many of these senior colleagues at the later of their career, how many of them are, postdoc or PhD student? And are they starting putting their foot on the map, or they're on the peripheral? So that's from the time perspective, looking at the whole community evolving, because people will move to the later stage and new people will, start to present in the network. So I'm also thinking about inclusive. That's more about the space. For instance, some schools have large center, a lot of resources and a lot of tools and a lot of support, while others schools have less of that. So will that basically make some institution or some schools taking more space in the community versus other school barely have any present on the space? So I'm more thinking of, the evolvement from time dimension, also the evolvement from the space. Like, how can we help cultivate the new group of scholars and make them, be part of the community, from not having a name, by having a name, by having a lot of connections. And also, how can we make people from relatively smaller school, don't have a huge team, also be part of the community, allow them to, put themselves into the network. So that's the two dimension I'm thinking about.
These are great meta questions about our own collective adaptation or intelligence here. Thank you. Thank you, Ying.
Thank you.
Jim, what do you think?
Well, surprise, I think this, thank you, Rick. I really enjoyed this. This is very interesting, and it was great to see these different language models sort of contrasted in terms of the solutions they give. But as someone who has spent a large part of my career fitting multidimensional scaling and developing algorithms for clustering and graph fitting, I would caution us not to get too fixated on this. So, I think the dimensions don't necessarily have to mean much. After all, what we're doing here is embedding a graph into a two-dimensional space. And, it means something, but doesn't mean that much. Also, I'm afraid, I've been blown away by the quality of the talks, and I thank you all for sharing your work in this forum. But, in a way, this graph is putting names in front of us rather than ideas. So some of us have strong association between the names and the ideas, and some of us don't. So I almost think that, if we're going to wrap things up and look for bridges between ideas, maybe Rob's tentative list of 7 themes might be a nice prompt to have before us, as well as the space. The space is pretty, don't get me wrong, but I think it's, it's dangerous. We might get fixated on a certain way of thinking about the problem of things.
Yeah, just a quick response. I completely agree. And I think that I was excited to share it and very, very happy to engage in dialogue about it, because it is a prompt to potentially think about connections and clusters. But yeah, I think that that tentativeness should always accompany interpreting that any such output, especially with a small data set of that sort as well.
Well, it's more that, I think of this, when you're engaged in collaborative thinking with others, you have to avoid freezing into premature takes on the subject. And I think I just don't want to keep it in front of us during this whole period. I mean, again, I'm sorry to stick my opinion in there, but don't get me wrong. I love the graphs. I'm going to share them with my students. So
I think they're great. And I also like that each one of them provides a little bit different picture. And so I really see this as kind of Rorschach test for us to kind of reflect and also convince ourselves that different techniques will give different kind of answers to this, and none of them is definite or anything. It's just kind of stimulate us to ask questions exactly like this: what is missing? What would be a good way to summarize and move forward? And I agree, we could reflect again on Rob's list. I did like your words, bird cloud, also, Rick.
Yeah, I stopped sharing that because I thought, Rob, if you want, I would enjoy seeing that. Actually, I don't know if.
Shall we share your? I mean, everybody can see it in the chat window. I know I cannot share. Rob, would you like to share your list?
Sorry,
oh,
I jumped the gun.
Sure, so actually, Arun, there you go. Great, yeah. So both Jim and Arun have it. Jim's is at, and right, there's some additional ones in Jim's list that, and Arun has the sub points too, I believe, in his.
Yeah, I took the comments from the chat, put them in the document so that we can use it for later. So, and I've been perusing it closely to just look at it from a different angle. Like, I agree with Jim in the sense that it's very easy to get impression with a graph like that right at the end of the workshop, where if we had missed 1 or 2 meetings from before and we didn't listen to one of the speakers, this might seem like a good summary and we might think, okay, this is overall what this workshop is about. But I guess in each session that I have been attending so far, there have been many emergent themes that are very difficult to just summarize in itself, and each of them were like discussions at length, and connecting them is probably possible, but at the same time, each of them are like an area of their own, something that needs to be explored independently before we can bring them back to a common theme. Because the deeper we went into certain topics, the more we learned about the different interconnected fields, and then it was more natural in the way that connected with the other topics, rather than, yes, we talk about computer assisted learning and then we look at like collaborative learning, for example, and then we just say, okay, these two might be interesting topics to just club around because there were some common words or like themes that emerged. But it would be more interesting to see like if when we dig deeper into a certain topic, that actually naturally connects to the other themes. So that's kind of what I was thinking as I was reading through Rob's list.
My interpretation of these different themes is that I think Rob is trying to kind of find the main eigenvectors across all the different topics, and ideally that's probably how we want to self-organize, right? In writing these different reports up, in terms of kind of being as orthogonal as possible, but at the same time we're going to cross-cut across a lot of common topics as well, right? And I guess like just to try to kind of aid in this process, I feel like there's definitely some natural language processing methods we could use to try to find these kind of eigenvectors of different topics, right? I mean, we don't necessarily have to. It's nice to be able to kind of connect this, but I think Rob has already done kind of the human work in producing this, and I think this is already seems like a very good set of themes to organize ourselves around.
I'm just posting into chat in addition to these potential themes for discussion, which are kind of domain level themes, if you wish. I found it interesting that some kind of more meta level question emerged while looking at Rick's presentation graphs, and I think those are really interesting, deep questions also. Like, what is adaptation? What is the goal of augmented intelligence? What is the appropriate time scale? And what are different spatial scales? And then maybe what are different methodologies and ways it can be used to study augmented intelligence? They are all, I guess, they intersect with all these potential topic level themes that Jean has helpfully posted. It's Celia, Christina. Celia, please go ahead. You are muted.
We can't hear you, Celia.
Thank you. My enthusiasm led me to forget to unmute. The enthusiasm was for, such a great list of meta questions, and an inclination to perhaps add one to do with meta. The issue seems to have come up several times. How important is it that the components of a system know that they are components, or that somehow the network or the system represents that it is a network or a system. So I suppose that could be encapsulated in how important is it that there is some kind of meta representation of the network.
That's great. I love this. Christina.
Cecilia's comment, I'll put there are from the living systems perspective attributes of living systems that say like that the system needs to know about itself, basically. I'll find the link and put that in. But I was able to host Howard Rheingold talking about his pedagogy method and rules for participants in real-time calls, where you have like, if a group like this wanted to have collective intelligence emerge that was like less ephemeral, more long-term, and create knowledge libraries and shared context over a longer period of time. Here's the roles that he defines for, some people say, I want to search. Some people say, I want to map it out. Some people say, I want to like identify terms for the lexicon. I would be super excited to see this group, which is really extraordinary in so many ways, do this next year. We could literally like watch the talks from this year again and actually kind of gel some of these things, or do it with the next talks. But it requires some after the call work and a lot of real commitment to community over time. So it's not like a lightweight thing at all.
Thank you. Yeah, excellent suggestion. I would like to recognize that we are near the end, and I would also like to say hi to Peng. It's great that you could join at the end. I was wondering if you wanted to, say hi, because this is our last session, and also in the email to us, you mentioned a new opportunity that just out. If you want to say something before we close. And thank you very much for your support, for your kind presence, and your guidance, yeah, take it away. Thank you.
So first, let me thank the organizers, Rob, Myrta, and Galton, for this wonderful workshop. And I think you're all in agreement on sort of the many interesting things that have come out of it. I'm very excited about some of the discussions and the comments that you've made. And I've indicated to the organizers that there are funding opportunities available, including to the program for a research coordination network to sort of keep this group together and to possibly expand. And just coming in on the last part of this presentation, I apologize, I couldn't come earlier. I'm in the middle of conducting a panel review. So I'm stepping out to just make sure I have time to say this to you, that just catching the last part of the discussion, there are certain things, especially with regard to that could come out of the analysis of how you're interacting as a group, even in this workshop, and the ideas that are developing henceforth. And I want to also point to NSF as a mechanism for exploratory research, to do proof of concept studies. And I would also encourage, as you think about moving forward together, and things that you might want to test and actually develop experiments, let me know. I would certainly be happy to consider some what we call exploratory research proposals. These are generally for 1 or 2 years and up to 300K. So there might be things you as a group could be doing to sort of test out some of the ideas that might have been in all your various talks, and to see sort of the And I was very interested in the comment also, which was also true for me, that as we listen to the talks, the interconnectedness that were not apparent in our initial grouping of some of these talks become more apparent. And that's, in some ways, it's sort of delving deeper in what are we thinking about augmented intelligence and the various directions that could be pulled together to build a more robust foundation of thinking about this topic. So I want to thank all of you, the presenters. So many of you have presented, and I hope you will continue to do more work on this. And I certainly am interested in exploring funding opportunities that could help you with your work, individually or collectively.
Thank you very much.
Yeah.
But before we end, Marina, Rob, would you like to say anything?
Yeah, thanks everyone again for your excellent participation in the workshop. I think I learned a lot, and I'm really glad to have helped to organize it. And yeah, I hope we can find ways to stay in touch after the end of the workshop. I will disseminate a final survey in a couple of days with a couple pointers and a couple questions to you in terms of how we could keep this group connected. And I hope we could gather some of your ideas on that. Thanks again, everyone.
Thank you, Marina. I was highly
thank you.
remiss. You've been an important part of this organization. Thank you.
Extremely important.
Thanks, everybody.
Please,
I'm a firm believer in self-organization, even more so after a result of this workshop. So I'm confident that we will keep on in some way, that organizations, once they're created, have a tendency to want to keep their persistence going.
For better or worse. Wonderful. Thank you all. Have wonderful holidays, rest, and go into the new year refreshed and full of great ideas. It was great to spend time with you all.